Okay, so these are the same types of problems as yesterday, the partial fractions, but now instead of just having a linear factor, so a linear would be x, it'd be 2x, it'd be 2x plus 6. Any of these are linear factors. It does not have a square on the x, so like 2x squared plus 4, that's now a quadratic factor, so that's going to be dealt with later this week. Everything we're dealing with yesterday and today are just linear factors. So this right here, this cube, a lot of people want to treat that as a cubic factor. It is not. It is really x minus 1 3 times, and if you look, all of these factors are linear. So this is called a repeat linear factor. So all you have to do is we say, okay, we have 3 of those, so we're going to have 3 fractions that came together. So we're going to put x minus 1. Now if you put x minus 1 for all of these denominators, if we were to get a common denominator, because remember, that's our goal, we're splitting this apart, the common denominator over here is x minus 1. That's not what we started with. We had x minus 1 cubed. So what you do for a repeat linear is you have to have every degree leading up to the cube. So we have x to the first, to the second, and to the third. Now we just put our a, b, and c on the top, and it's the same problem from here. So we want to clear our denominators. So we'll multiply by my original. If you want, you could put x minus 1, x minus 1, x minus 1. If that helps you, you can. But you could also write x minus 1 cubed. So those cancel. We have 2x. We distribute that to every factor. So there's 1 in the bottom. That means a is left with x minus 1 squared. 2 are going to cancel, so b is left with x minus 1. And everything will cancel with c. Make sure you do the cancellation. Otherwise, this becomes extremely long and messy. So we have 2x. If I foil this out, I'm going to get x squared minus 2x plus 1. I didn't distribute the a yet, but we could have. Bx minus b plus c. So then I've got one more step to get this all multiplied out. 2ax plus a plus bx minus b plus c. Okay. And then remember, we're just looking for like terms. So all my x squared, which is just a, have to equal all the x squareds over here, which is 0. Then we'll go to the x's. So we've got, I usually underline them first just so I don't miss anything. Negative 2a plus b, that has to equal 2. Then we've got my constants. Oops, I almost missed b. So we've got a minus b plus c, that also has to equal 0. Then you do the same process. We plug this in as a matrix. So I'll put this up here. You guys know how to do these at this point. This is a 3 by 4. 1, 0, 0, 0, negative 2, 1, 0, 2, 1, negative 1, 1, and 0. We'll solve the matrix. That tells me that a is 0, we knew that. B is 2, and C is 2. So remember, your final answer are the fractions that came together. This is not your final answer. You go back up here, and you actually put your numbers in there. So since a is 0, that term just goes away. 2 and 2. That was the decomposition of 2x over x minus 1 cubed.